In January 1966, the United States launched a hydrogen bomb in the Mediterranean Sea. Planes, ships, submarines, nothing could find it. What found it was a formula written by a minister who died 200 years earlier and never even published it. That same formula decides whether your medical test result means anything, whether an email reaches your inbox, and whether a self-driving car thinks that shadow is a person. And study after study shows trained professionals struggle with it. So try it yourself. A disease hits one person in 100. The test catches 99% of the sick and wrongly flags 1% of the healthy. Yours comes back positive. How worried should you be? If your gut says 99%, hold that thought. By the end, you will get this right when most people do not, and watch the same reasoning guide a search for a lost nuclear weapon. To understand how a formula finds a bomb, meet the man who never wanted you to see it. Thomas Bayes, a minister, worked out the rule of belief and put it in a drawer. It was published after his death by his friend Richard Price. And here is the surprising context. The world this formula landed in was consumed by a debate about miracles and evidence. David Hume's skepticism on one side and Price, armed with probability, on the other. The mathematics of cold rationality grew up inside a theological argument. Laplace rediscovered the idea independently and gave it engines, turning inverse probability into a working scientific method. He attached betting odds to his astronomical estimates in writing, and modern measurements have been kind to his numbers. Quantified confidence 2 centuries early. Then came the long exile. As frequentist statistics rose to dominance in the 20th century, Bayesian methods became deeply controversial in the academy. Yet in insurance offices, actuaries ran a quiet practical tradition of exactly this kind of reasoning, credibility theory, because it worked. Theory argued. Practice build. At Bletchley Park, Alan Turing used it to crack Enigma. He measured evidence in a unity called the band, a decibel of belief. Every clue added decibans, and when the needle crossed the threshold, a code setting was declared broken. Remember this meter. It comes back at the end, inside your phone. His 2 papers on the method stayed classified for 70 years. GCHQ released them in 2012. The math was a state secret into the smartphone era. One more thing. There is no verified portrait of Bayes. The picture in every textbook is probably not him, the father of belief updating, and we cannot even update our belief about his face. So what did he actually write down? Not a formula first. A way of thinking. Bayes thought like a detective, and his method is a machine. 2 things go in, what you believed before, the prior, and 1 new piece of evidence. 1 thing comes out, what you believe now. 10% hunch. Clue 1. Seen nearby. Through the machine, 35%. And now the move that makes it Bayesian, that output slides back around and becomes the next prior. Clue 2. Matching boots. 65. Clue 3. No alibi. 82. Believe. Observe. Update. Update. Repeat. Belief is a running process, not a verdict. A stadium with 60,000 fans and exactly 1 pickpocket. Your scanner is 99% accurate. Sweep the crowd and it flags 600 innocent people and probably the thief. A flag does not mean guilt. It means 1 of 601. The crowd size was the whole story. Now the trap. The killer wore a red jacket and your suspect owns one. Feel the belief shoot up. Now zoom out. 500 other people were wearing red that night. Watch the belief fall right back. A clue only moves you by how rare it is. How surprising. Hold that word. Every update is this seesaw. On one side, how well the evidence fits your story. On the other, how easily it fits any story at all. Belief only moves when your story explains the evidence better than the world at large does. That seesaw is the entire formula. One more picture before the math. Spread your belief out as a landscape. Every possible answer is a place, and the hill sits over the places you find plausible. Then evidence lands over there ethically, and the whole landscape physically reshapes, mass flows toward what the evidence favors, and the hill sharpens. Bayes does not hand you certainty. It reshapes the terrain of what you think is possible. Time to write it down and close in on that test result. Here it is. The posterior equals the likelihood times the prior divided by the evidence. Nothing new. The prior is your bar. The top of the seesaw is the numerator. The bottom is the denominator. You have been doing this math for 5 minutes. First, throw away the sloppy phrase 99% ACCU rate. It hides two different dials. Sensitivity of the people who are sick. It catches 99%. Specificity of the healthy. It correctly clears 99%. And one more number that outranks both. Only 1% in 100 has the disease at all. Now watch it as a crowd, not a formula. 10,000 people. Zoom out. 1% are sick, about 100 people, and the test catches 99 of them. Paint them red. But the test also wrongly flags 1% of the 9,900 healthy people. That is another 99, painted yellow. Now look closely at the two crowds. Pour all 10,000 people down a funnel. Left branch, the 100 sick, the test catches 99. Right branch, 9,900 healthy, and 1% of them, another 99, get flagged anyway. At the bottom of the funnel, 198 positives, and the two streams feeding them are exactly the same size. So, of the people holding a positive result, how many are actually sick? 99 out of 198, 50%. Your terrifying positive test is a coin flip. The quiet one in 100 prevalence carried as much weight as the entire test. And now look again at the formula because it was describing this funnel all along. The prior is the left branch. The likelihood is how the test treats it. The denominator is every own at the bottom. The equation is just the funnel written sideways. And here is the working engineer's version. Flip to odds and updating becomes multiplication, or on Turing's meter, addition. Every piece of evidence just adds its decibans. Chain 100 clues, add 100 numbers. That is why this form cracked enigma. One picture to keep. The confusion grid. True alarms, false alarms, misses, and the quiet majority. Every term of Bayes lives in one of these four boxes, and every metric in machine learning is a ratio of them. Now, about that bomb. Palomares, Spain, January 1966. A B-52 collides with a tanker, one bomb falls into the sea. The Navy draws a grid over the seabed and asks, what is the probability the bomb is in each square? And the strongest evidence for the starting map comes from an unlikely expert, a local fisherman, Francisco Simo Ortiz, who watched something fall on a parachute. The squares his sighting favors glow brightest. Then the insight that makes the whole method work. Search a bright cell and find nothing. That is evidence. 2. The empty cell darkens, and every unsearched cell gets a little brighter. The search itself was generating evidence. But here is the subtlety the Navy got right. Not finding something is only evidence if you know how likely you were to find it. Search murky water and see nothing. The cell barely dims. You probably would have missed it anyway. Search clear water and see nothing. The cell collapses. Same emptiness, different evidence. About 80 days after the crash, roughly 2,500 feet down, the bomb came up, close to where the shrinking map pointed. Bayesian reasoning did not tell the Navy where the bomb was. It told them how to become less wrong after every failed search. 2 years later, probabilistic search combined with hydroacoustic evidence helped narrow the hunt for the lost submarine Scorpion. And in 2011, after 2 years of failed searches for Air France 447, a Bayesian reanalysis, fed by the negative evidence of every earlier failure, helped define the area where the wreck was found within days of the renewed search. It finds lost others too. In 1964, two statisticians ran word frequencies through Bayes to settle who wrote the disputed Federalist Papers. The needle said Madison. That analysis is the great-grandfather of every AI that attributes text today. And once you see it, it is everywhere. Spam filters, Paul Graham 2002, medical screening, search ranking, A/B tests, a robot keeping a probabilistic map of where it probably is. Recommendations. An agent maintaining a belief state about a world it cannot fully see. All of it prior, evidence, updated belief, repeat. And you can build the bomb search yourself in 6 lines. A grid of priors. Each empty search multiplies by the missed likelihood, renormalize, and ask the map where to look next. That is the entire Navy algorithm. The full notebook is in the description. Stories are nice, but where exactly does Bayes live inside a neural network? Let us open one up. Here is the spam filters AC2L math, naive Bayes. Every word in the email is a witness. For each one, the filter asks the surprise question: how much more often does this word appear in spam than in normal mail? The log of that ratio is the word's evidence in decibans. Watch the trial. Free, heavily spammy, +6. Offer, +4. 3 exclamation marks, +5. But meeting testifies for the defense, -5. Tomorrow, -2. Sum the decibans. And the needle crosses the spam line. Verdict delivered by pure addition. That is a base update per word in log space, exactly Turing's enigma arithmetic in your inbox. Now the formula nobody derives for you. Take base over many classes, cat, dog, car. Write each class's evidence as a log score, call it Z. Substitute back, and Bayes' theorem becomes e to the z over the sum of e to the z. Look at it. That is softmax. The layer at the end of every classifier is not a design choice. It is Bayes' theorem exponentiated, which means the logits feeding it are log evidence, decibels again, and the softmax temperature you tune. That is you deciding how much to trust the evidence. Turn it up, the posterior flattens toward the prior. It was Bayes all along. Last one, and it is the deepest. Look at the loss function you minimize every day. The first term, cross entropy, is the negative log likelihood. How well do the weights explain the data? And the second term, rate decay, the thing you copied from a tutorial, take its log seriously, and it is a Gaussian PRI, a belief held before seeing any data that weights are probably small, likelihood plus prior. So minimizing your loss is maximizing the posterior over the weights. Every training run you have ever launched was a Bayes update, the data arguing with your prior, one gradient step at a time. And the biggest Bayesian machine of all is the one writing your emails. Now zoom out to the biggest Bayesian machine ever built. A language model writes by holding a posterior over the next word, 50,000 candidates, reweighted after every single token of context. Watch the belief shift as evidence arrives. Add 2 words, found by, and the distribution tightens. Add one more piece of context, and fisherman surges. Because THIJ's conversation has been about Palomares for 10 minutes. The context window is evidence. Every token you type is a Bayes update on what comes next. And the frontier is teaching models to carry their uncertainty. Honestly, the Bayesian family of methods keeps a posterior, not a verdict. What if intelligence is not just knowing the answer, but knowing how uncertain you should be? A trustworthy system needs 3 different sentences, I know. I think. I do not have enough evidence. One picture to live with. A prior. Evidence weighed by surprise. An updated belief which becomes the next prior. Now watch the same loop bear 4 different costumes. The doctor, disease prior plus a positive test. Turing setting prior plus an intercepted message. Palomares, location prior plus a failed search. The AI, object prior plus camera and LiDAR. Different problems. The SAMI question, now that I know this, what should I believe? Bayesian thinking does not ask you to be certain. It asks you to be updatable. Because intelligence is not having the right beliefs. It is knowing how to update them. If this click, season 3 builds the whole machinery, probability, likelihood, entropy, one tool at a time. Thanks for watching and keep exploring. Next time, probability, the language of uncertainty. Please like and subscribe ThirdEye Labs if you enjoyed this video, and let me know in the comments.